Hi and welcome back. This is class 5 of this series of tutorials, and in this class we are going to add some variations in the density and the velocity sourcing. Well, for me, a good emission makes for 60 to 70% of the look of the simulation. So we are going to see what controls we can add to our volume sourcing to bring enough variations in the emission. So let's get back in there in the wall emitter. As I told you, I'm going to use this branch, so I'm going to delete this one. Okay. And just organize this a little bit more. There we go. All right, so we had this before, so here we are interpolating our points, remember? Okay, so that our points are playing correctly here and nicely with all the parameters, the attributes that are transferred correctly from the animation. I should delete this blast, should deactivate it. Okay, so now is about adding the variation, as I said. So we are going to see how to do that for the density and then for the velocity. Okay, now if we think about the emission here, how this would be emitting some dust in the air. What I would say is that the first thing is that, okay, we emit from the points, like I said, around at the surface of the geometry, but really it should be that the back of each fragment should be emitting and not the front of it, okay, because we have the dust as a trail just behind it. Just the dust is left behind the movement of the fragment. So that's one thing. Then there is also, obviously, maybe the most obvious actually, that it emits only when it moves. Okay, so that the dust is trailed behind because of the wind peeling it off the surface. So all the fragments that are static here at this moment are not emitting much, and then the faster they go, the more they emit. And also maybe, I mean, they don't have infinite amount of dust on them, so at some point they should stop. And because they don't have all the same amount of dust, there should be a variation between the fragments. Okay, so we are going to see how we can add each of these individual elements that I just mentioned. And the first one I'm going to deal with is the variation per fragment here. So to be able to vary something per fragment, I need to have an ID, some way to identify the fragment individually. And we should have this, because if you remember, I cached the name attribute on each fragment. All right. So this is one way of dealing with that. I'm going to use this name attribute to be able to vary the information per fragment. So let's go here. How can I make this? So let's see if I can do actually a color and see if this name attribute is working. So I have the fragment here, and I'm going to do a random from attribute there, and I'm going to use the name. Okay, so I need to do on the primitive attribute, because here the name is on the primitive attribute, and I need to delete attribute delete just before. I need to reset the CD and the points before. There we go. So okay, so the name is giving us some way to vary the information here on each fragment. So this should be something I can use to vary the density. So the first way I can think about to vary the density is to use an attribute randomize, attribute randomize. There we go. So this one here, we are going to set it to density. It's going to randomize the attributes on the point. Okay. So here, let's keep visualizing density here. Okay, so we have a color in the density, which is normal because we set that to 3. Instead, I'm going to put that to 1. So it's a one dimension because density is just a float and not a vector. Okay, so it's a one dimension. And now if I check the density here, idle attributes and show me the density. Now we have some random values between all the points, but we don't have them per fragment because, as I mentioned here, we need the name attribute. And so we are going to randomize according to the name attribute. And so I need to use the name as a seed attribute. Okay, still not working because the name here is not on the point level. Okay, this is an attribute that is not there anymore. Here we have it on the primitive level. Okay, we don't have it on the point level. And then when we pass the attribute interpolate, we don't have it. This is because I didn't pass anything here. So if I do that, then you can see it's already working. We have the name attribute that is passed to the point. Now it's available here at the point level. And so when on the attribute you say, well, use the name to seed, then it's using the name. And for each different name, you have a different variation in the density. Okay, so then you can play with the seed, vary, put whatever you want here to have some variations. And if you want to change the variation of the density, then you can play with this. You can increase the amount of density or decrease the amount of density. You can change the minimum value as well. You can put something which is going to -1 if you want something negative in case. Okay, so that's the one way, and I'm going to call that randomized density. As you noticed, we don't have to initialize the density before, but I like to do that just in case. I like to take this good habit of initializing my attributes before actually doing something to them. So you can create the attribute before, initialize it to a value of 1, and then do a randomize to it. Okay. If you don't like to have that much node, well, you can go for the randomized density. But just be careful. Sometimes you might have some unwanted behavior. The other method I can think of to vary the density requires a bit of vex. Okay, so in case you're familiar with it or you want to learn vex, maybe you want this method. So we said we want some variation with the name attribute, the per fragment. Usually when you do some attribute wrangle here, and if you want to vary something, you use the random function here. But this random function doesn't take any string parameter here. It does take an integer or a float. So let's say I go to the help. Here, yeah, it takes a float, not even an integer. It takes a float, but any integer you pass into it is going to be converted anyway to a float. So if you want to use a random, you won't be able to use the name attribute. You won't be able to do that. So you need to find a way to actually transfer some integer attribute. And the way I do this is I create an attribute wrangle here. Okay, at this level. Here I have the name, so I'm going to set to primitive because I have the name at the primitive level here. And I'm going to put an expression here to create an ID attribute. Okay, so it's going to be an integer ID attribute. And if you look here at the name, we have digits at the end of the name. And so, was it? Okay, sorry. It errors, so it's not happy. There we go. So we have some digits, and they're all different for each fragment. So my idea is to extract this number from the rest of the name. And so if we look at the name, if we take the name, there is a function which is called split index. Okay, so if I take this function and I go to the help, please take me to the help. Yeah, it splits a string into tokens. Okay, so if you split S, you will have an array of different values. But you could split S with a separator. You can specify the separator here. So I'm going to say split my name, okay, according to this separator. All right, so it's going to split the name. If I go here, it's going to split the name into chunk and 12, which is what I want. And so I'm going to keep only the second one. And remember, arrays, they start at 0, we have chunk, and then at 1 we have the second one, token. Okay, the first is 0, the second is 1, and then you would have 2, 3, 4, 5 starts at 0. So yeah, this is it. And then I need to put that into my ID attribute. And then if I go, okay, what's happening there? Okay, let's. Okay, it doesn't want to cast this to an integer. So I need to convert the integer to a string, and this function is a to I. Okay, so sorry, I need to convert the string to an integer. So it converts the string a to an integer. Okay, and now it's working. And now you see we extracted the ID from the name. And if I go down, I should have exactly the same. You can check on your side as well, but we have this ID there. So here I'm going to do this, create ID. We have ID at the primitive level, which is good. Okay. A little bit of comment there. Extract ID from the name attribute. Okay. Is it going in the interpolation here? So if I go there, I have the ID, yes, because it was at the primitive level, and now I'm transferring everything. Do I need the name? Not really. For now, I'm going to keep it just in case I need it in the rest of the setup. But later, maybe I will clean it. And so here, if I go and do density, so float density equals random, I can do a random at ID now because it is available. And if we look at it, we should have some variation according to the ID. And then I can change the seed. Okay, so the way you change the seed is by just adding some values there, and this is the way you change it. Okay, you could obviously quickly set up parameter for the seed, so you could do that, and it's float channel. CH is channel and F is float, channel float. Okay, and I'm going to call that seed, and then I press the magic button here, and then I have the seed, and then if I yeah, okay, obviously I need to use it, otherwise it's useless. And then if you play with this parameter, you have the seed changing. Okay, so we just mimic here the thing we've done here with this method, where you actually change the global seed as well. Okay, so choose the method you want. If you want to learn Vex, maybe this is the way. Density randomize. Okay, with this you don't need to actually create it before, because when you do this, it actually creates the density attribute, initialize it correctly to 0, and then you pass something into it. If you want to be even more rigorous, you could do this equals 0. Okay, and then you pass some values into it. Now we can keep working on the density and add some even more variations. So let me clean this a little bit. I'm going to rename density, create, just for clarity, density randomize. Okay, now just one thing, I think I didn't mention that. Yeah, you have some. You have some options here where you can play with it, and you can use also the custom ramp here. Okay, and if you play with that, then you can see that you can change the variation of the actual density. So we have more fragments with higher density, and here, if we do that, well, then we have less of them. We have more density at 0, and then we move all the way up to 1. And then you can change the contrast between the fragments. Maybe you don't want this one. Maybe you want to just more variation, more fragments with a density of 1. This is a way to quickly do that. If you want to do this here, you would need to make a ramp attribute, a ramp parameter. So float ramp equals shrimp. Okay, this is the name, and I'm going to call that density density ramp. Okay, and I'll create this. So we have this this one here, and now, yeah, sorry, the ramp is not working because we need to give it some parameter that is going to go at the input here, and this parameter as an input should be my random, the random that we have here. So instead of doing the rand here, I would do it here. Okay, there. And this float ramp here now should go into the density. Okay, and so if I visualize this, now we have this, but then you can see you can play with that in the same way we were playing with it in the density randomize here. I'm going to put that at the same level. All right, 2 ways of doing the same thing, one with Vex, the other one using the usual node, the default subs. Now I would like to add some noise, so I'm going to bring this one back, and it's going to be called density noise. Okay, so here I'm going to noise the density, and if I visualize this there, okay, get rid of this. Let's remove the variation for now so I can see my noise and see the contribution of the noise only, and then I will bring back the randomize here. So here's the noise. If I play with the element size, then I can have something which is a bit closer to what I want, which is a noise like small enough to have some variation per fragment and not for the entire range, you see. So now I have this. If I press play, you see that the fragments are actually moving through the texture. The noise is not static per fragment, okay, on each fragment. It's actually, if you look at this one, it's the most obvious, I think. You see that it's moving through a 3D texture, which is static in space. And the reason why we have this is because we are using the location attribute, which is P. And P is the global position, the world position of the point. All right, so it's changing all the time. So if you don't want this to be changing with the movement, then you need to use a rest position. Okay, we need to use the position that we have at some point in time, and usually a good thing is to use the first frame. Not necessarily, but usually it's what we do. So here I have this. I think I'm going to put it here because I have a static frame. I have my points. So it seems to me like a good way, a good position for that. And you can use the rest node, okay, here. If you put it here, it's going to create for you a rest attribute. You could also do an attribute create with the and naming that rest, and then putting here the value. It's a 3. It's a vector. Okay, so it's a vector, it's changing it. And then you could do add p.x and then put the p.y and then add p.z. And then if we look at the rest attribute, it's on the point position. Then I go here. You would have here the rest position. Either way, you can look at this one, then you have the same values. Yes. Okay, so either way you choose, you could do an attribute create, you could even do an attribute wrangle, and I said I would show you. So you do, so it's a vector rest equals v at p. Okay, and because we are here on the time shift, under the time shift, which is frozen to frame 1, then all of these methods are working correctly. Okay. I'm going to with the rest just because it has a nice icon. So now we have this rest attribute. If I go to the noise here and I display visualize this and I do rest. Now, well, it's obviously changing, but we should see that the fragments have, and now we can see it here, have the same noise per fragment. It's not moving. Okay, so use the rest position if you want to have a static noise per fragment. So I think I'm good now with the density variation. I'm going to put this back on. Okay, maybe I could bring back in some density here. Okay, it's up to you now. You know how this works, so you can play with that. So I'm going to keep this branch. This one, I leave it now. I mean, you can copy that in your setup. Now, the next thing I would like to work on is the emission per fragment for the speed regarding this in terms of speed. Sorry, we said that the ones that are static, we don't want them to emit anything, and the ones that are moving, we want them to emit some density. So we are going to play with that. To do that, I'm going to do an attribute wrangle. And for this one, I think I'm going to go full wrangle. Okay, so I'm going to do to call that speed. And the first thing we need to do is to actually calculate the speed. The speed is, by convention, the length of the velocity. Okay, so we create a speed attribute and we say it's the length, okay, of, length of the velocity attribute. Okay, now we have this, it's on the point. I'm going to visualize it. We should have it somewhere here. Where is it? Speed, idle attribute, speed, there we go. So I'm going to visualize it and say speed here, okay, and then if I rewind, you see that we have no speed, and then after the impact we have some movement, and it goes to from 0 to 1. The black one are the ones that are static, that are not moving much, with a really low velocity. And the other one are actually moving with a speed higher than 1, so that's why you have really bright red. Okay, so we have this. Now we can use this speed to control how much density we want. But I don't want to affect the density immediately with this. I'm going to use intermediate attribute, which I'm going to call emit. Okay. This emit attribute is like a switch or some kind of not just a switch on off, but a variation that goes from 0 to 1. I would like it to go from 0 to 1 in order then to multiply the density. So then I would have density times equals f at emit. Okay, so when emit equals 1, then we would have the density equals to what it was before. But then if density is emit equals 0, then we have 0. And then if it's 0.5, then it's going in between. Okay, so you get the idea of this emit. So final density for now, I'm going to call that. This emission here is the one that is going to be controlled by speed. And so what I want to say, okay, if you have no speed, so if speed equals 0, then you should have an emission of 0, okay? So if my, f at speed equals 0, all right, then you should have an emission of 0, and that's what we have here. But if the speed is greater than some threshold, and for instance, I say as soon as you move, but you move with a decent speed, and let's say maybe 0.5 for now, or 1, then emit should be 1. Okay, so I'm going to copy this. Okay, so something is not working. F at speed equals 0. Equals. Yeah, sorry, my God. So yeah, we have this. So when you have something which is not moving, you have full 0 here. Remember that before that, the speed, if we look at the speed here, we didn't have like a full black. It was almost black, okay? It was like really low value. But now with this method, when I'm doing this, and I'm actually clamping that to 0, and I can change the threshold. So this one is 1, and if it's above 1, then you have 1. But what's in between, we didn't define it. What's in between the 0 and the 1? So really, here in my case, I should do emit equals 0. Okay, yeah, and if you're above 1, then you have a value of 1. Now I can change this threshold value, and you can see if I change it, then more and more fragments are actually going red. And then if I increase the speed, the threshold speed, then only when the speed is higher than 10, you have some density, you have some emission, and then the density is reflected in the emission. So here I'm going to use a threshold value. Okay, so I call that threshold. And I'm going to define this as a float threshold. Did I write it the same way? Yes, float threshold. And it's a channel float because I have a float parameter here, float variable, and I'm going to call that threshold. And I missed this magic button. And then if I do now, if I play with this, then you can see that you are actually increasing and changing everything here. Okay. So a little bit of cleanup here. Variable creations, we do that at the top. Then we have the final density, then emit variation. Okay, so I put the emit here as an attribute. We don't necessarily need that, but I mean, in this case, because everything is used in there, so we wouldn't need it. But I'm getting a little bit ahead of myself, because I know that the emit, I'm going to use it later on down the network. So that's why I used it as an attribute. But the speed here, really, we don't need to have it as an attribute. Okay, really, I created it so we can see it here, but we can say this is just a float, and then here remove that. So we say, by doing this, we say this is just a variable and not an attribute. And then you see it disappears here, and you don't have it here anymore on the attribute. That means that it's that much less information that is passed into the memory. Okay, not much in this case. It's just a float, but with a lot of points and with vectors, and then you accumulate the attributes, then you are cluttering your memory. So try and keep this clean, or as clean as possible. Okay, so we've done the density and we've done the speed. Now is a good time to do a checkpoint and see if it's still working with our mission. So I am going to go back here, activate this, rewind. Okay, so we can see that. I'm going in there. Because I'm lazy, I don't want to recache this just for now, just to do a test. Then what I'm going to do is plug this onto the rasterize there. And I'm going to check that it's actually doing something. Yeah, maybe my laziness is going to cost me. No, it's fine. We see it. Okay, so it's still working. We see that we have some more variation than before. I'm going to press play here. Okay, fine. So we have some variation. The fragments that we have here, let me see if we actually can see them. Okay, so we have the fragments. The noise seems to be working. I'm going to increase the speed threshold here, just to be sure it's actually doing something. So we're playing here. We should not have any emission at the beginning. Let me hide this. And this is the case so far. And remember, it was starting, the speed was, yeah, you can see this here now. Maybe it's a bit, maybe the visualization here is not really good. So I'm going to dive in there. Remember, no, I didn't put any visualization, so I'm going here. On the smoke, visualize there, multi-field, okay, because we are visualizing the multi-field. I'm going to increase the density scale. There we have it, okay. So it's working. Yeah, I was looking for here for the volume visualization. You can put it here and increase the density here. maybe it's better to have it here. So we have this, it's actually working, the speed, the noise is also working. Maybe I can play with the randomize now. So I'm going to put this back here and play with the randomize. So for the randomize, I'm going to have less, I'm going rewind, always rewind so that when you change a value, it doesn't try and recalculate the entire simulation. But then I'm going to do that, checking that the fragments, yes, sorry, hide other object. That's another way of, okay, so we check that the fragments, you have much less fragment with a density, with big density. So that's good. All right. And now if I go up there and I display, it's calculating the simulation up to frame 72. Okay. It's a bit faster as well because we are not displaying every time the density. All right. Yeah, it's emitting from the beginning, but it's emitting a lot of dust still. I thought we would have much less. So what's happening here? Density randomize, and I visualize the density. There's no density, but maybe it's not zero completely. Maybe because of the noise. If I remove the noise, then I should have only these fragments. So let's try that again. Yes. We only have a few fragments emitting, really. So that's good. Let me display the fragments again. There. Okay, cool. Well, that concludes this part. Well, this class 5. There's still other things I would like to do, but I'll do that in the part 2 of this class, which will be class 6. Okay, see you in a bit.